Welcome to our deep dive into the structure of a Bitcoin block. In this video, we'll explore what a block is, its components, and how it fits into the larger Bitcoin network. Let's get started. First, let's define what a Bitcoin block is. A Bitcoin block is a collection of transactions that are bundled together and added to the Bitcoin blockchain. Each block contains a series of transactions that have been verified by miners and are ready to be permanently recorded on the blockchain. Blocks are linked together in a chronological chain, forming the blockchain, which serves as a public ledger of all Bitcoin transactions. Now, let's discuss why blocks are crucial in the Bitcoin network. 1. Transaction verification. Blocks help verify and confirm transactions. When transactions are included in a block, they are considered confirmed and are added to the public ledger. 2. Security. The structure of blocks ensures the security of the Bitcoin network. Each block contains a cryptographic hash of the previous block, linking them together and making it nearly impossible to alter any previous block without changing all subsequent blocks. 3. Decentralization. Blocks contribute to the decentralized nature of Bitcoin. By distributing blocks across a network of nodes, Bitcoin ensures that no single entity controls the entire network. Let's break down the components of a Bitcoin block. A Bitcoin block consists of several key components. Let's start with the block header. The block header contains metadata about the block. It includes the following fields. Version indicates the version of the Bitcoin protocol being used. Previous block hash, a cryptographic hash of the previous block, linking the blocks together. Merkle root, a hash that represents all transactions in the block, ensuring data integrity. Timestamp, the time when the block was created, expressed in Unix time format. Difficulty target, a measure of how difficult it is to find a new block, adjusted approximately every 2 weeks. Nonce, a random number used in the mining process to find a valid hash. Next, we have the transaction counter. The transaction counter indicates the number of transactions included in the block. This helps nodes understand how many transactions they need to process. Now, let's talk about the transaction list. The transaction list contains all the transactions that are part of the block. Each transaction includes details such as the sender's and receiver's addresses, the amount being transferred, and the transaction ID. Next, we have the Merkle root. The Merkle root is a cryptographic hash that represents all the transactions in the block. It is created by hashing pairs of transaction hashes together until only one hash remains. This structure ensures data integrity and allows for efficient verification of transactions. Now let's discuss the nonce. The nonce is a random number used by miners when trying to find a valid hash for the block header. Miners continually change the nonce and hash the block header until they find a hash that meets the network's difficulty target. Next up is the timestamp. The timestamp records when the block was created. This is important for maintaining the chronological order of transactions in the blockchain. Now, let's look at the difficulty target. The difficulty target is a measure that determines how hard it is to find a new block. The Bitcoin network adjusts this target approximately every 2 weeks to ensure that blocks are added to the blockchain roughly every 10 minutes. Finally, we have the previous block hash. The previous block hash is a cryptographic hash of the preceding block. This links the blocks together and creates a secure chain, ensuring that any alteration to a previous block would invalidate all subsequent blocks. Now that we understand the structure of a block, let's briefly discuss how blocks are created. Blocks are created through a process called mining. Miners use powerful computers to solve complex mathematical problems, competing to find the correct nonce that produces a valid hash for the block header. Once a miner successfully creates a new block, they broadcast it to the network. Other nodes verify the block and its transactions before adding it to their own copy of the blockchain. Finally, let's discuss how the block structure contributes to the security of the Bitcoin network. The cryptographic hash linking each block to its predecessor ensures that altering any block would require recalculating the hashes of all subsequent blocks, which is computationally infeasible. Additionally, the decentralized nature of the Bitcoin network means that no single entity controls the blockchain. This makes it resistant to attacks and censorship. In summary, a Bitcoin block is a fundamental component of the blockchain structure, containing essential information such as the block header, transaction list, and cryptographic hashes. Understanding the block structure is crucial for grasping how Bitcoin and blockchain technology function. Thank you for watching. If you found this video informative, please like, share, and subscribe for more insights into Bitcoin and cryptocurrency.